Welcome back to The Explainer. Focused learners, I am absolutely thrilled you're here today. We are jumping right into a hands-on journey to demystify basic programming. We aren't just going to sit around talking about abstract theory. Nope, we're building a highly practical solution from scratch. And the best part? Whether you're aiming to write software in JavaScript, Python, Java, C++, C, or C#, the universal concepts we're tackling today are the literal bedrock of them all. We are going to build a program, so grab your mental hard hats because we are getting straight to work.
Okay, let's look at our problem statement. How do we write a program that defines a function to calculate the sum of two integers and prints the result? And how do we actually use it by passing it two specific numbers like 5 and 3? It sounds incredibly simple, right? But honestly, mastering this single operation unlocks the exact same logic used to build massive web applications and complex operating systems. We are quite literally going to teach the computer how to do our math for us.
So here is our simple problem-solving roadmap. Step 1, define a function. Step 2, add the numbers inside that function. And Step 3, call the function and print the result. Boom. Let's just dive right into Step 1.
Right, Step 1 was defining a function. But what actually is that? Well, as our sources point out, a function is a reusable block of code designed to carry out a specific task. I like to think of it like a custom-built machine. If you need to add two numbers together multiple times in your code, you definitely don't want to repeat that addition logic over and over again. That's just inefficient. Instead, you build a sum machine. You hand it your raw materials, your inputs, it processes them, and then it hands you back a finished product.
Let's actually look at how we write this out in JavaScript. We start with the keyword function, followed by the name we want to give it. In this case, sum. Then we have parentheses holding a and b. Now these are our parameters. Think of them as empty slots just waiting for data. We're essentially telling the computer, hey, I'm building a machine called sum, and it requires two pieces of information to work, which I'll temporarily call a and b. And those curly braces that follow? Those are the walls of our factory. All the processing logic is going to happen right inside them.
So the really crucial point here is understanding what happens to our inputs. We have our intended input values, the integers 5 and 3, and then we have the internal process, which is a plus b. Inside our function, we use the arithmetic addition operator, the good old plus sign, to combine whatever is placed into slot A with whatever is placed into slot B. The computer doesn't even care that they are 5 and 3 yet. It just knows that when the time comes, it absolutely must add those two distinct inputs together.
But wait a second. Once the computer actually calculates a plus b, where does that result go? It needs a safe place to live in the computer's memory. Enter the variable. Our sources use a really fantastic analogy here. A variable is like a container or a box used to store data. Imagine buying a bottle of water. Our source uses a popular brand called Eva. Because the bottle is labeled Eva, you can easily ask someone to grab it for you from a crowded fridge. In JavaScript, we give our data a name, so whenever we need that specific value later, we simply call its name, and the computer fetches the exact contents of that container.
Let's see how that actually looks in the code. Inside our function, we write let add equals a plus b. We're using the let keyword, which is a modern ES6 JavaScript feature for declaring variables, basically replacing the older var keyword. And we're naming our container add. Now, the equal sign here, it's not asking if things are equal. Actually, scratch that. It's more like a command. It's an assignment operator. It tells the computer, take the result of a plus b and assign it to, or securely store it inside, the container named add.
Okay, so we have our results safely stored in our add variable. But here's a funny little quirk about computers. They keep their work hidden by default. If we don't explicitly command the program to show us the result, it's just going to do the math, store the answer, and remain completely silent. No way we want that. So to reveal the contents of our variable, we use console.log add. This is a built-in command that prints whatever is inside the parentheses directly to the developer console. It's basically our way of demanding from the machine, hey, show me what you made.
Let's look at our completely assembled machine now. Just see how beautifully this all comes together. We have function sum a b. Inside the curly braces, we initialize our variable. Let add equals a plus b. And then immediately on the next line, we print it. Console.log add. Those curly braces neatly enclose our entire operation. We have successfully built a reusable block of code that takes two inputs, adds them, stores the result, and prints it right out. Our machine is fully constructed and sitting on the factory floor.
But, and this is a really crucial rule of programming, simply defining a function doesn't actually run it. It literally just sits there, waiting.
To make it work, we have to actively invoke it or call it. We do this by writing the function's name, followed by parentheses, and then providing the actual data, the arguments we want it to process. By typing sum5,3, we are finally flipping the switch, turning the machine on, and feeding the integer 5 into slot A and the integer 3 into slot B.
Let's just pause for a second and trace the exact sequence of events the computer executes behind the scenes, usually in a fraction of a millisecond when that final line of code is triggered. First, the function sum of AB is called. The computer assigns the value 5 to the parameter A and 3 to B. Next, dropping down into the curly braces, it performs the actual arithmetic, 5 plus 3. Then, it takes that resulting value and securely stores it in the memory container, that variable we named add. Finally, it executes the console.log command, peering inside the add container to find the final number to print.
And the output? Yep, it's 8. Honestly, there is nothing quite as satisfying as writing a set of instructions, passing in your data, and seeing the computer execute your logic flawlessly to produce the exact correct output. Our program works perfectly. We mapped out our approach, we translated it into syntax, we created variables to hold our data, and we used a function to make the whole shebang completely reusable.
Which brings us to our final thought for today. The gap between writing a simple sum function and building a massively complex web application? It's really just a matter of scale, not a change in the fundamental physics of programming. You just used variables, parameters, assignment operators, and functions. Whether you're coding in JavaScript, Python, Java, C++, C, or C#, these are the exact same building blocks used by senior developers at the world's biggest tech companies. So my question to you, focused learner, is this. If you can teach a computer to add 2 numbers, what complex, world-changing problem are you going to solve next? Keep coding, and we'll see you in the next explainer.